Hi, Professor. My name is Young. I'm in the same group with Shamin, and I would love to show you the Python programming part of this project. So we use Google Colab for this Python project. This is diabetes prediction model. So there are some main parts in here. There are in total 7 part: important data set, data understanding, modeling, fine-tuning, evaluation, and feature importance. So first, I would need to connect it to my Google Drive because it has the dataset and then I import the libraries and packages that I need. And they're mainly from the models and evaluations, mainly from scikit-learn. Right, so next step is I'll look around at the dataset to see is there anything interested. And I double check to see if there is any empty value, and it seems not. So I continue to check the data type. There's no string in here, so I don't need to deal with that. So I will assume that the data at this point is already cleaned. So next step is some data understanding. I just do some general uh, graph plots because it tell me more than just number. So here there's a huge or a big gap between the number of people who have diabetes and people who don't. So this may affect the model. Then I look around more to see the relation between the features and also the label or the outcome. So from the age, um, there are like a lot of people got diabetes during like in between, let's say it's 27 to around 43, but there are even more people who don't have that around the age of like 15 to 25. And I don't just stop there, so I keep going and then try to see is there any like correlation between different features. So I look at the age versus blood pressure. It doesn't give me much amount of information. The distribution of the scatter plot here are the same as what the age versus PMI and blood pressure. So I just continue. Um, so this is the PMI distribution. It also doesn't tell me much because both of them looks they're at the same like uh place. So I will just continue to see is there I continue to the matrix. Um, so this is the heat map of the correlation matrix. The darker color will stand for more correlation of that feature to the label. So here I found that the the outcome is affected a lot by the amount of glucose in the body. So after this I started looking at the graph between glucose and insulin because from a heat map insulin also contribute quite a lot. Not at much, but yeah. Then double check it. However, I feel like between glucose and insulin, it doesn't tell me much, but it seems like it's good to go here. And yeah, so I just continue to the modeling part. So first step first, I will divide the data set into the modeling part and the test part. So the test part will include 20% of the data set. The training part is 80%. In this case, I'm using three main models: logistic regression, K-Burn, classifier, and random forest. I just fit them all in those model without any tuning. We just here we are using default model first to see how is their performance. It gives me pretty solid outcome. Logistic regression with 82% of accuracy, KNN 75%, random forest 81%. So I believe there's more to improve, so I start doing fine tuning part. First I fine tune KNN. It's simply just we just give the k neighbor number from 1 to 21, and then we choose the best number. The one we choose can then n neighbor that give the best outcome. So here we found that the best one during this fine tuning is 79%. So almost 80%. Then again we fine tune another model, logistic regression. We used random forest grid, and it includes technically some of the attribute that is put into the model. So also another one randomly put it in, and then to try to get the performance, and then we'll compare its performance with the old models to see which one work better. So we can decide if we choose the fine-tuned one or the old model. And then here I also fine-tune the random forest model using the same technique. After that, we compare the new models with old models. So it seems that after fine-tuning, logistic regression and KNN models work better, but the random forest after fine-tuning it is worse. So after this step, we decided to we found that logistic regression is the best model, right? So since it is the best model after fine-tuning, we will choose that one to evaluate only. So first we make so remember when we break that when we split the data set into 20% of test data. So we use the model to predict that data set, and then we evaluate the score. So after evaluation, we draw a this is called confusion matrix. It's pretty confused. On the left hand side is true label, and is the y-axis, and the x-axis is predicted label. So the 001 here is here. It is predicted as 0, but the true label is 0 here, so it's worked pretty well. However, I can see here there are 19 of that people that actually get diabetes, but our model predicted wrong. Luckily, this number is not a big number. However, it still show that the model is not that like sure on how to predict people who have diabetes. So if we look at the score from the confusion matrix, it is here. There's analysis here. So let's just focus on the class 1, since that is what I talked about. So 78% of predicted diabetes case were correct, but there's only 60% of actual diabetes case. So it means that 40% of true diabetes case were missed. So this is a huge, like it's not a huge number, but this is a very low performance of this model. And one of the reason for this is because of the data set is not that big. And like I said at the beginning, there is a big difference between the number of people who have diabetes and the number of people who don't at the beginning. That's why it affects a lot. So in the future, we may want to improve that. Here are just another graph of that report. And then the last step is feature importance. I want to see which feature contribute the most to the label. And after a few steps, we found that diabetes pituitary function contribute the most to the label, and the other features seems not contribute anything much. So first of all, the model did some good thing. It have high recall and high accuracy for class 0, which is the, the class of people who don't have diabetes. And the overall accuracy is pretty good, which means that it is not overfitted or underfitted as well. So in the future, there are more to improve, especially the dataset. It can be improved so that our model will work better. And as the dataset get bigger, we may change to different models, not just rainforest or logistic regression. And that's it.